In the depths of ancient Egypt, when the Nile's waters reflected stars that seemed to govern the fate of empires, there existed a terror that haunted the night sky. The Egyptians called it Apophis, or Apep. This wasn't just any mythological creature. This was the cosmic serpent of pure chaos, the devourer of light itself, locked in eternal battle with Ra, the sun god. Every single night, as Ra sailed his solar bark across the heavens, Apophis would emerge from the underworld to swallow him whole. The serpent's massive coils could wrap around the entire world, and its bite meant the end of everything. To the ancient Egyptians, this wasn't just a story. It was the fundamental struggle between order and oblivion that played out above their heads. But here's what's truly unsettling about this ancient tale. On June 19th, 2004, three astronomers working at the Kitt Peak Observatory in Arizona were scanning the night sky with their telescope, completely unaware that they were about to discover something that would make that ancient Egyptian nightmare seem almost prophetic. Roy Tucker, David Thalwin, and Fabrizio Bernardi were conducting routine observations when they spotted a faint point of light moving against the background stars. At first glance, it looked like just another asteroid, one of thousands of space rocks that astronomers catalog every year. But as they tracked this object and began calculating its orbital path, something extraordinary started to emerge from their data. This wasn't just any asteroid. This was something heading directly toward Earth. The initial calculations were rough, but they sent shivers down the spines of everyone who saw them. The object was large, approximately 370 meters across and shaped like a massive peanut. It was traveling at tremendous speed through space, and according to their preliminary orbital mechanics, it had a very real chance of colliding with our planet on April 13th, 2029. Now, you might think that's quite a coincidence. Discovering an object named after the ancient Egyptian god of destruction, only to find it approaching Earth on Friday the 13th. But the universe, it seems, has a rather dark sense of humor. As word spread through the astronomical community, telescopes around the world began tracking this mysterious visitor. With each new observation, with each refined calculation, the picture became clearer and more terrifying. The asteroid they designated as 99,942, Apophis, wasn't just passing by our neighborhood. It was coming closer to Earth than any object of its size in recorded history. Dr. Steve Chesley at NASA's Jet Propulsion Laboratory spent sleepless nights running and rerunning the orbital calculations. Each time, the numbers told the same chilling story. There was a genuine possibility, initially calculated at about 2.7%, that this cosmic serpent would strike Earth with devastating force. NASA Science, https://science.nasa.gov/solar-system/asteroids/apophis/. The discovery of Apophis marked humanity's first real encounter with a cosmic threat we could see coming decades in advance. It forced us to confront uncomfortable truths about our vulnerability in a cosmic shooting gallery, where objects capable of ending civilizations are constantly in motion. most of them completely unknown until spotted by vigilant astronomers with extraordinary dedication. So, we've established that Apophis exists, that it's heading our way, and that it's named after an ancient god of destruction. But what exactly are we dealing with here? What makes this particular chunk of space rock so uniquely significant that it captured the attention of astronomers worldwide and changed how we think about planetary defense? Let's start with the scale. When we say Apophis is approximately 370 meters long, that number might not immediately convey the true magnitude of what we're facing. But let me help you visualize exactly what we're talking about. Picture the Empire State Building, that iconic Art Deco skyscraper that dominated the New York skyline for decades. From its base to the tip of its antenna, it stands about 443 meters tall. Apophis is roughly 84% of that height, but instead of standing majestically in Manhattan, it's tumbling end over end through space at speeds that would make a supersonic jet look stationary. NASA Apophis facts: https://science.nasa.gov/solar-systems/asteroids/apophi's-facts/. But here's where it gets even more fascinating. Apophis isn't shaped like a building at all. Recent radar observations have revealed that it's what astronomers call an elongated, irregularly shaped object that resembles a massive peanut tumbling through space. The asteroid measures approximately 450 meters by 170 meters, making it significantly longer than it is wide. This peanut-like shape creates some fascinating and potentially dangerous complications. Unlike a spherical asteroid that rotates predictably, Apophis tumbles in a complex pattern that takes just over 30 hours to complete one full rotation. Imagine trying to predict the exact trajectory of a football spinning through the air, except this football is the size of several city blocks. It's 25 years away from reaching you, and the slightest miscalculation could mean the difference between a spectacular light show and a regional catastrophe. The composition of this cosmic projectile is equally intriguing and concerning. Spectroscopic analysis indicates that Apophis is classified as an S-type asteroid, composed primarily of silicate, rocky materials mixed with metallic nickel and iron. This classification places it in the same category as ordinary chondrite meteorites, dense, solid rock and metal that doesn't disintegrate easily when encountering atmospheric friction. Space reference: https://www.spacereference.org/asteroid/994-2-APOPHIS-2004-MN4. If Apophis were to impact Earth, it wouldn't burn up harmlessly in our atmosphere like the smaller meteors we see streaking across the night sky. Its size and density mean it would punch through our atmospheric defenses with devastating efficiency, delivering its full kinetic energy to whatever unfortunate region of our planet happened to be in its path. The challenge of tracking this cosmic projectile cannot be overstated. Apophis is what astronomers call a relatively dark object, with its surface reflecting only about 23% of the sunlight that hits it, making it roughly as reflective as charcoal. Detecting and tracking this object against the backdrop of space is like trying to find a black car on a dark highway at midnight while wearing sunglasses. This low reflectivity is why the discovery of Apophis was such a remarkable achievement. The astronomers who first spotted it were essentially detecting an object roughly the size of 3 football fields, traveling at tremendous speed millions of miles away, and reflecting barely 1/4 of the light that hits it. It's a testament to the incredible precision of modern astronomical instruments and the dedication of the scientists who operate them. Recent radar observations have revealed details that are both fascinating and sobering. We now know Apophis's rotation period to within minutes, approximately 30.56 hours. We know its approximate mass, estimated at around 61 million tons. That's roughly equivalent to 2,000 fully loaded aircraft carriers, all compressed into a space smaller than 4 city blocks. When this cosmic bullet passes by Earth in 2029, it will be moving at approximately 28,000 kilometers per hour relative to our planet. At that speed, it could travel from New York to Los Angeles in about 10 minutes. The kinetic energy contained in that motion is almost incomprehensible, equivalent to more than 1,150 megatons of TNT if it were to impact Earth, roughly 23 times the explosive power of the largest nuclear weapon ever detonated. But perhaps the most challenging aspect of studying Apophis isn't its size or speed. It's the extraordinary precision required to predict its trajectory decades into the future. Predicting the path of an asteroid 25 years in advance requires an almost impossible level of accuracy, where even microscopic measurement errors can compound dramatically over time. Understanding Apophis's journey to Earth requires us to explore one of the most complex aspects of celestial mechanics, the intricate gravitational dance that will determine whether this cosmic visitor becomes humanity's greatest spectacle or our greatest challenge. Apophis doesn't travel through empty space in a straight line. Instead, it navigates what we might call a gravitational obstacle course, a complex environment where the gravitational fields of multiple celestial bodies constantly influence its trajectory. Every planet, every large asteroid, even our own moon exerts subtle but measurable forces on Apophis as it completes its 324-day orbit around the Sun. The asteroid's orbital path is distinctly elliptical, bringing it as close as 107 million kilometers to the Sun at its nearest point, then swinging out to about 166 million kilometers at its farthest. Earth's orbit lies right in the middle of this range at approximately 150 million kilometers from the Sun, which is precisely why our paths intersect at all. But here's where the story becomes both fascinating and terrifying. The concept of gravitational keyholes. Picture Earth's gravitational influence as a vast invisible funnel, extending hundreds of thousands of kilometers into space. As objects approach this gravitational field, their trajectories get bent and twisted by our planet's pull. Most of the time, This gravitational influence simply deflects objects harmlessly past us. However, scattered throughout this gravitational field are tiny regions, keyholes, where an object's trajectory could be altered in just the right way to set up a future collision. These keyholes are incredibly small, some less than a kilometer wide, but if Apophis were to pass through one during its 2029 flyby, Earth's gravity could nudge its orbit just enough to bring it back on a collision course in 2036 or beyond. Recent studies have confirmed that while Apophis will safely pass by Earth in 2029, the gravitational interaction during this encounter will slightly modify the asteroid's orbit. The exact nature of this modification depends on the precise path Apophis takes through Earth's gravitational field, a path that must be predicted with extraordinary accuracy to determine whether we're truly safe from future encounters. The Planetary Society, https://www.articles/articles/apophis-it-earth. The precision required for these calculations is staggering. We're talking about predicting the trajectory of an object 25 years in advance to an accuracy measured in meters, not kilometers. To put that in perspective, imagine trying to predict exactly where a baseball thrown from New York would land in Los Angeles, accounting for every gust of wind, every change in air pressure, and every microscopic variation in Earth's gravitational field along the way. Adding to this complexity is the Yarkovsky effect, a phenomenon so subtle it wasn't even discovered until the 1990s, but potentially crucial for understanding Apophis's long-term trajectory. As the asteroid rotates, the side facing the sun heats up during its day and cools down during its night. However, there's a thermal lag. The surface doesn't immediately re-radiate all the heat it absorbs, creates a tiny but persistent thrust, like having a rocket engine so weak you could barely detect it, but one that fires continuously for decades. Over the years between now and 2029, this minuscule force could shift Apophis's trajectory by several dozen kilometers, Apophis's trilometers, Apophis's trajectory by several dozen kilometers. Seemingly small change that becomes critically important when trying to determine whether the asteroid will pass through gravitational keyholes measured in meters. The gravitational interactions become even more complex when we consider that Earth itself isn't a perfect sphere with uniform density. Our planet bulges at the equator due to its rotation, and variations in surface features and subsurface density create tiny irregularities in the gravitational field that can influence a close approaching object's trajectory. April 13th, 2029. This date represents one of the most significant astronomical events in human history, the day when asteroid Apophis will make its closest approach to Earth, passing closer than our satellites and closer than any object of its size in recorded history. The encounter will be visible to an estimated 2 billion people across Africa, Europe, and Western Asia, marking the first time a potentially hazardous asteroid of this magnitude has been observable to the naked eye during such a close approach. Space.com, https://www.space.com/astronomy/asteroids/2-billion-people-will-be-a-pophs eyes dash when dash it dash buzzes dash earth dash in dash April dash 22-9. Apophis will pass just 31,600 kilometers above Earth's surface, closer than many of our geostationary satellites, which orbit at approximately 36,000 kilometers altitude. If Earth were the size of a basketball, Apophis would pass by at a distance of about 2.5 centimeters, close enough to almost brush the surface. During its closest approach, Apophis will shine at magnitude 3.1, making it roughly as bright as the stars in the Big Dipper and easily visible to anyone looking up at the right time, even from moderately light-polluted urban areas. For observers along the asteroid's ground track, it will appear as a fast-moving star that visibly races across the sky in real time. No telescope required to witness this cosmic spectacle. The asteroid's path will take it on a dramatic journey across Earth's sky, starting from the southern hemisphere, where observers in parts of Australia and the Pacific will be the first to spot it. As Earth rotates and Apophis continues its trajectory, the asteroid will sweep across the Atlantic Ocean region, moving from south to north at tremendous speed. But April 13th, 2029, represents far more than just a spectacular sky show. This date will mark the greatest scientific opportunity in human history to study a large asteroid at close range, using our modern array of instruments and techniques. The European Space Agency's Ramses mission, currently in development for launch in April 2028, will rendezvous with Apophis in February 2029, 2 months before the close approach. The spacecraft will accompany the asteroid during its entire encounter with Earth, providing unprecedented close-up observations and measurements that would be impossible from Earth-based telescopes alone. ESA Ramses mission, https://www.esa.igntis/space_safety. Planetary_defense Ramses_ESS_mission_to_asteroid_Apophis. Ground-based observatories around the world are coordinating what will essentially be the largest astronomical observation campaign ever mounted. Radio telescopes will bounce radar signals off Apophis's surface, mapping its shape and composition in unprecedented detail. Optical telescopes will study its surface properties, rotation, and any signs of structural changes induced by Earth's gravitational field. Infrared observations will map temperature variations across the asteroid's surface as it rotates through sunlight and shadow. The scientific data collected during this encounter will serve multiple crucial purposes. First, it will provide the precise measurements needed to definitively determine Apophis's future trajectory and eliminate uncertainty about potential future impacts. Second, it will serve as a real-world validation of our planetary defense capabilities, testing our ability to track, predict, and monitor potentially hazardous objects with the accuracy needed for effective defense planning. Perhaps most importantly, the 2029 flyby will demonstrate how Earth's gravity affects a large asteroid during a close encounter. Scientists will be able to observe in real time how our planet's gravitational field alters Apophis's rotation, orbit, and potentially even its internal structure. This information will be invaluable for understanding how gravitational interactions could be used as tools for planetary defense in future scenarios. The study of Apophis has catalyzed a revolution in planetary defense, the emerging field dedicated to protecting Earth from cosmic impacts. What began as theoretical discussions among astronomers has evolved into active international programs, developing real technologies to detect, track, and potentially deflect threatening asteroids. The success of NASA's DART double asteroid redirection test mission in 2022 marked a pivotal moment in this field. By successfully altering the orbit of the asteroid Dimorphos, DART proved that kinetic impactor technology, essentially ramming a spacecraft into an asteroid at high speed, can effectively change an asteroid's trajectory under the right conditions. NASA DART mission https://science.nasa.gov/planetary-defense-dart/closing parenthesis. However, recent research has revealed a sophisticated challenge that planetary defense planners must navigate carefully: the gravitational keyhole effect. Scientists have discovered that poorly planned deflection attempts could inadvertently nudge an asteroid through these tiny gravitational keyholes, potentially setting up future collision courses rather than preventing them. This research emphasizes that asteroid deflection isn't simply about pushing space rocks away from Earth. It requires extraordinary precision to ensure that deflection efforts don't accidentally create new threats. The implications are sobering. Deflection missions must be planned with mathematical precision that accounts not just for the immediate trajectory change, but for the long-term gravitational interactions that could occur decades or centuries later. For an object like Apophis, several deflection strategies have been proposed and analyzed. Kinetic impactors remain the most straightforward approach, but deflecting Apophis would require a much more massive and powerful impactor than the DART spacecraft. The asteroid's estimated 61 million tons of mass means it would require substantial force to produce a meaningful change in trajectory. Alternative approaches include gravity tractor missions, where a spacecraft hovers near the asteroid for extended periods, using its own gravitational field to gradually pull the asteroid off its collision course. While this technique doesn't risk fragmenting the target asteroid, it requires years of operation to produce significant trajectory changes, meaning such missions would need to be deployed well in advance of any potential impact. The nuclear option, using nuclear explosives to deflect or destroy threatening asteroids, remains controversial but continues to be studied. The primary advantage is the enormous energy available in nuclear devices, but the challenges are equally significant. International treaties restricting nuclear weapons in space, technical hurdles in designing nuclear systems for asteroid deflection, and the risk that nuclear explosions might fragment large asteroids into multiple, smaller pieces that could still cause significant damage. Current surveys have identified approximately 90% of the largest near-Earth asteroids, those over a kilometer in diameter that could cause global catastrophe. However, smaller objects like Apophis, which could cause regional devastation, are much more numerous and difficult to detect. The Vera C. Rubin Observatory, scheduled to begin operations in the mid-2020s, will revolutionize our ability to discover potentially hazardous asteroids, potentially increasing our catalog by an order of magnitude within its first decade of Operation DOT as we approach the historic 2029 encounter with Apophis. We stand at the threshold of what historians may someday call the age of cosmic awareness, a fundamental shift in human consciousness about our place in the universe and our relationship with cosmic threats. The Apophis encounter represents more than just an astronomical event. It symbolizes humanity's transition from passive victims of cosmic chance to active defenders of our planetary home. For the first time in our species' existence, we have advance warning of a genuinely large cosmic visitor, time to prepare for its arrival, and the technological capability to study it in unprecedented detail. Current predictions indicate that Apophis will pass safely by Earth in 2029, with follow-up observations expected to rule out impact threats for at least the next century. However, the lessons learned from studying this asteroid extend far beyond the object itself. Apophis has served as humanity's cosmic teacher, forcing us to develop the technologies, international cooperation frameworks, and scientific methodologies needed to address future threats. The asteroid population in Earth's vicinity includes thousands of objects we haven't discovered yet. Every year, survey telescopes find several hundred new near-Earth asteroids, each requiring follow-up observations to determine whether they pose any threat. It's a continuous process of cosmic inventory, where each new discovery adds to our growing catalog of objects that need monitoring and analysis. Consider asteroid Bennu, currently being studied by NASA's OSIRIS-REx mission, which has a small but measurable chance of impacting Earth between 2175 and 2199, or 1950 DA, a kilometer-wide asteroid with roughly a 0.3% chance of hitting Earth on March 16th, 2880. Examples demonstrate that cosmic threats operate on timescales far longer than human civilizations, requiring sustained vigilance across generations. The implications extend beyond just scientific curiosity. Knowledge that cosmic impacts are statistical inevitabilities over geological timescales is influencing discussions about humanity's long-term survival strategies. Space exploration programs are increasingly viewed through the lens of species survival, with proposals for lunar bases, Mars colonies, and other off-world settlements gaining support partly as potential refuges for human civilization. Organizations like the United Nations Office for Outer Space Affairs have established the International Asteroid Warning Network and Space Mission Planning Advisory Group specifically to coordinate planetary defense efforts globally. These organizations are developing protocols for sharing asteroid discovery data, assessing potential threats, and coordinating deflection missions if they become necessary. The transformation in public consciousness is equally significant. Educational programs are teaching children about asteroids and planetary defense alongside traditional subjects. Popular culture increasingly features scenarios where humanity must defend Earth from cosmic threats. The general public is becoming more scientifically literate about cosmic risks and the technologies needed to address them. As we count down to April 13th, 2029, Apophis has already achieved something remarkable. It has fundamentally changed how our species thinks about cosmic threats and our ability to address them. This ancient wanderer, named after the Egyptian god of chaos, has paradoxically brought order to our approach to planetary defense. The technologies being developed to study and potentially deflect Apophis have applications far beyond planetary defense. The same techniques that could redirect a threatening asteroid could be used to capture asteroids for resource extraction, redirect comets to provide water for space colonies, or alter the orbits of small moons around other planets. We're developing the tools not just to defend our planet, but to actively manage our local cosmic environment. Looking toward the future, we can envision advanced survey telescopes maintaining constant watch for new threats, with automated spacecraft stationed throughout the inner solar system, ready to intercept and deflect dangerous objects years or decades before they could threaten Earth. The cosmic wanderers that once threatened our extinction could become the building blocks for an expanding human civilization, but this transformation won't happen automatically. It requires sustained commitment to space science and technology, international cooperation on unprecedented scales, and the wisdom to make decisions about cosmic threats based on scientific evidence rather than political considerations. The alternative, remaining vulnerable to the next cosmic visitor that might not be as accommodating as Apophis, is simply unacceptable for a species with the capability to defend itself. Apophis will make its historic close approach in just a few short years, passing within 31,600 kilometers of Earth's surface at 28,000 kilometers per hour. For a few hours, this cosmic serpent will dominate our skies, visible to billions of people as a fast-moving star racing across the heavens. Scientists will gather unprecedented data about its composition, structure, and behavior. Engineers will test planetary defense technologies under real-world conditions, but perhaps most importantly, humanity will take a giant step forward in our cosmic evolution. We will prove that we can detect, track, and study objects capable of ending our civilization. We will demonstrate international cooperation in addressing threats that transcend national boundaries. We will show that science and technology can triumph over ancient fears. The ancient Egyptians saw Apophis as the cosmic serpent of chaos, the eternal enemy of order and light. But the modern Apophis, our Apophis, has become something entirely different. It has become a catalyst for human advancement, a teacher that has forced us to develop the capabilities needed to secure our species. Long-term survival dot as this cosmic visitor continues its ancient orbit around the sun. It carries with it the knowledge that it has fundamentally altered the trajectory of human civilization. We are no longer the same species that once cowered in fear at celestial omens. We are becoming the active guardians of our own cosmic neighborhood and perhaps someday the shepherds of an entire solar system. The encounter with Apophis in 2029 will mark not an ending, but a beginning, the dawn of humanity's age as a spacefaring civilization, capable of defending itself against the cosmic forces that have shaped our planet's history for billions of years. The ancient prophecy of destruction has been transformed into a modern promise of protection. Friday the 13th, 2029, will be remembered not as a day of fear, but as the day humanity proved it could face the cosmos as an equal partner in the ancient dance of celestial mechanics. The serpent of chaos has taught us well, and we will be ready for whatever the universe sends our way next.